All right, so we are looking at, let's see, 2.3 real zeros of polynomial functions. So we're going to look at some ways to find the zeros. Right, the zeros are where it crosses the x-axis. Real zeros are. Imaginary zeros, it does not cross the x-axis, so we'll talk about imaginary numbers and stuff in a couple more sections. But today we're going to look at real zeros, so basically algebraically being able to find areas that these polynomials cross the x-axis once you set them equal to zero, once you set the function equal to zero. That's not what I want. If I can move that over here. I guess not. All right, we're just going to have to deal with that on there. All right, so let me see if I can put this in presentation mode. And now it's not moving. All right, so what's going on here? Oh, I think it's moving now. It's just slow. Oops. All right, so here's the things we're going to look at. We're going to look at long division of polynomials, which you may have seen before. And then we're also going to look at synthetic division, which is a little bit easier way to divide, but it only works in certain cases. And some of these theorems, we're going to look at some of them, and we're not going to look at some of them. We're not going to look at Descartes' rule. We are going to look at the rational zero test to help us determine what are some rational zeros of polynomial functions. So the biggest thing to get started with is getting this division, long division and synthetic division of polynomials. Okay, so before we worry about any zeros or anything like that, we are going to look at just long division. So the first problem they present us with is this polynomial right here, 6x cubed minus 19x squared plus 16x minus 4. And they put the graph on there, and they said, notice that x equals 2, which is this one right over here, appears to be a zero of this function, and this one's sort of in between points, so it's really tough to just look on there and tell. But that does look like it goes through 2. So what they're saying is that if x equals 2 is a 0, and that means that x minus 2 is a factor. So does everybody remember that? Let me slide this over. If we have a function and that is in factored form, we did this some in the last. If I have x minus 2 times x plus 4. All right, if we have the function in factored form and we set it equal to 0, to find the zeros of that function, then if you recall, what we do is we simply take each factor and set it equal to 0. All right, and then you solve it. So here, the two zeros, I would add 2, and I would get x equals 2. And here I would subtract 4, and I would get x equals -4. So if you notice, the zeros come, it's like they're opposite from the factor. If the factor is x minus 2, the 0 is actually positive 2 because we have to do the opposite when we solve for 0, right? Same thing if we have a 0 of -4, that comes from the factor of x plus 4. So that's what they're doing right over here, is they're saying that a 0 is at 2 because it crosses the x-axis at 2 on their graph. All right. And so that that factor of x equals 2 comes from that 0 of 2 comes from the factor of x minus 2. All right, so if we were looking at what this polynomial is in factored form, we would know that x minus 2 is a factor of f of x. So based on this information up here, we know that this polynomial right here will factor as x minus 2 times, close the parentheses, times something. All right. And then this something is what we've got to use division to figure out. Okay. A lot of times polynomials won't factor. If it's a trinomial, we know there's ways to factor trinomials. There's ways to factor terms with 4 by grouping, but not all of them will factor. Okay. So they use the graph to determine that one of these zeros is 2. All right. And we are now looking for these other 2 zeros, which are right there in the graph. Okay. So because 2 is a 0, we know x minus 2 is a factor of this. So what we're going to do is we're going to use long division to figure out what is left right there when we factor out x minus 2. That's essentially what's happening here. Okay. So let's talk about long division. Now, this doesn't have anything to do with zeros. This is just doing long division. All right. And don't really want. So what we have is we have 6x cubed minus 19x squared. Right? Factors are multiplied together. So if I factor something out, the opposite of multiplying is dividing. So I can find what's left if I divide this by x minus 2, the factor x minus 2. Okay. Now, if we could factor 6x cubed minus 19x squared plus 16x minus 4 by grouping, we could, but that won't work. So what we're going to do is we're going to use long division. Long division is just like if you go back, if I wanted to say what is 6 divided into 165. All right. You remember how we would do that? We would look, 6 won't go into 1, but it'll go into 16. It'll go twice. So then I would multiply 2 times 6 to get 12. And then I would subtract, and I have 4. Then I would drop down the next one to 45. 6 goes into 45, 7 times? 7 times 6 is 42. I subtract, and then I would have a remainder of 3. And one thing we could do with that remainder is we could put it over 6, right? So that would be 27 and 3 over 6, or 27 and 1/2. So 6 divides into 165, 27 and 1/2 times. All right. Well, with polynomials, it's very similar. Okay. What we're going to do is the polynomial we're dividing into, we're going to put it inside the little bracket thing or the little division house. And so this is going to be 6x cubed. Now, the one thing you do have to be sure of is this polynomial has to be in descending order by degree, and you have to have every degree accounted for. from where you start. So if it starts with an x to the third, that means you have to have an x squared, an x, and then a constant. And if you skip over one of those, what you do is you just fill in a coefficient of 0 along with that variable. So if there wasn't an x squared term there, I would have put 0x squared to hold that place. But they're all here. So that's going to be 6x cubed minus 19x squared plus 16x minus 4. And then I'm going to divide that by x minus 2. All right. Now, here's how we do this. It's very similar to just regular numbers. Okay. I'll look at the first term here. Now, the same thing out here. Whatever I'm dividing out here, it has to have every degree with where it starts with down to the constant included. Well, this one just starts with an x to the first power, so we just have that in a constant. But what we do is we look at this and we say, okay, x times what is going to equal 6x to the third? Okay? And actually, I'm going to put it over here. It doesn't really matter, but x times what would give me 6x to 3? And I'll just line it up right here so it makes it. So I know if I wanted to take x times what to give me 6x cubed would be 6x squared. All right. Is everybody okay with that? And now what I do is I multiply just like we did before. 6x squared times x is 6x to the third. And then I have to also multiply it by this. 6x squared times negative 2 is negative 12x squared. And notice this is why we got to have place value holders. Notice my x cubes are lined up and my x squareds are lined up. And then we subtract. Now, I don't just subtract 6x cubed. I subtract the entire polynomial. So I have to basically distribute that negative through there. So if I'm going to subtract this entire thing, that would make this negative and it would make this positive. You basically just change the signs of every term there. And then what happens is that first term will add to 0. I set it up that way. And then the remainder of this is negative 19x squared plus 12x squared, which is a negative 7x squared. Then we take the next term and we drop it down. So that would be plus 16x. Now it's just a matter of repeating what I just did. All right. X times what would give me negative 7x squared? Well, x times negative 7x. Right? Negative 7x times x is negative 7x squared. Negative 7x times negative 2 would be positive, what, 14x? Now I'm going to subtract, so I'm just going to change the signs. That becomes a positive, so that adds to 0. This adds to 2x. And I drop down the minus 4. All right. Now x times what is 2x? That would be a positive 2. So that's going to be 2x minus 4. I change the signs. I get a remainder of 0. Now, going back to what we're doing, if x minus 2 is a factor of that polynomial, you're going to get a remainder of 0. If 2 really is a 0 of this polynomial, okay, this polynomial we started with, this polynomial right here, then when I divide it, you're going to get a remainder of 0. If I didn't get a remainder of 0 there, then 2 is not an actual 0 of this particular polynomial. Okay, so if you'll notice what I have there now is What is this factor now? F of x. We use the graph to get the factor of x minus 2. And then what's left when I factor out x minus 2 from the original polynomial is 6x squared minus 7x plus 2. So this is what I get when I factor out x minus 2 of this original polynomial. You notice they got the same thing, 6x squared minus 7x plus 2. Okay? So we used long division to break this down. All right? And let me go over here and write this out. So what we have, whoops, I need to slide it over. Is what was that original polynomial? 6x cubed minus 19x squared plus 16x. So in essence, what we're doing is we're trying to factor this polynomial. And because we got the 0 of 2 off the graph, we knew that x minus 2 was a factor of this, so we broke this down as x minus 2, and then we used long division to find the second part of it, 6x squared minus 7x plus 2. And this is our f of x. Now, there's two ways I can go about finding the two zeros that come from this. I could use my Pythagorean theorem, right? Not my Pythagorean theorem, the quadratic formula. Negative b plus or minus square root of b squared minus 4a c over 2a. All right. Or I can see if it will factor further. All right. So right now it will factor, so I'm going to go ahead and factor it. If you're going to have to recall back from your integrated 3 course on how to factor, I'll show you how I factor it. I factor by what's called the Berry method. And here's what I do. The way I factor it, I don't know why this thing. All right, is I put that 6x started out in both parentheses. All right. Then what I do is I multiply the first times the last one, and I get a positive 12. Now I need to know what will multiply to 12 and add to negative 7. Well, that would be a negative 4 and a negative 3. Now, when I put 6 in both positions, I increase this by a factor of 6, so I have to reduce it out. So I've got x minus 2. And then there's a common 2 there that's extra, so I've got to reduce that 2 out to make that 3x minus 2. And then there's an extra factor of 3, right? There was an extra factor of 2 there and an extra factor of 3. 2 times 3 is 6. When I double that up, I put in an extra factor of 6. No, so if I factor that out by 3, I'm going to have 2x minus 1. Now, you may have been taught to take factors of 6 and put it here and here, where it could be either 6 and 1 or 3 and 2. Then we put factors of 2, positive 2 there and there, and see which outers and inners add to that negative 7. And if you notice, negative 3, negative 4 add to negative 7. So there are my 3 factors. This is now completely factored. Okay, we started by getting the 0 of 2 and knowing that came from a factor of x minus 2. So what are my actual zeros? What are my zeros of this function? Well, I set each one of these equal to 0. X minus 2 equals 0. 3x minus 2 equals 0. And 2x minus 1 equals 0. So then I add 2 and I get x equals 2. Here I add 2 and divide by 3, so I'm going to get x equals 2/3. And here I add 1 and divide by 2, and I get x equals 1/2. So the 3 zeros, and remember, it started out as 6x to the cube, so a third degree we know can have at most 3 real zeros, and this one does have 3 real zeros, which we knew from the graph way back up here that it did cross the x-axis 3 times. 1, 2, 3. It crossed at 2, and then now we've found out it crossed at 2/3 and 1/2. All right, so that's how we found out. Now, it's sort of a long way to get there, but that's what we had to do. All right. Yes.
How did you get that?
How did I get 2x minus 1?
Yeah, and 3x minus 2. You
All right.
divide everything by 2.
Well, let me go back to here. So there's different ways to teach factoring of trinomials. Whoops. So let's go back. It came from this right here, 6x squared minus 7x plus 2. All right, so we've got to factor that trinomial. Do you remember at all factoring trinomials? They factor as 2 binomials. And some people teach, okay, here and here got to be factors of this, right? Because when you FOIL it back out, these two. So I could either put 6 and 1 or 1 and 6 or 3 and 2 or 2 and 3. And then here factors of 2 or 2 and 1. So I could put 2 here and 1 here and then just start looking at the combinations of outers and inners that would add to -7. The way I teach it is called the Berry method. And to me, it's a little more consistent because you could do the same thing every time. And what you do when on that is instead of looking at factors of this, I just put this number and the x in the first position of both of them. And then I multiply the lead coefficient by the constant, which is 12. And then I look factors of 12 that would add to -7, which is going to be -4 times -3. Now, the problem with the Berry method is if this is not an understood 1 here, then what I've actually done, 6x times 6x is actually 36x squared, right? So it's not correct. What I did is I inserted an extra factor of 6 in my factors that I've got to reduce out. And I look here, there's a 2 common to both the 6 and the 4. So 2 of that 6 is in this factor. So I just reduce it out. It's kind of like reducing a fraction. 2 goes into 6 3 times. 2 goes into 4 2 times. So that's actually 3x minus 2. And then this one is that other 3. 2 of the extra factor was there. 3 of it is here. 2 times 3 is 6, which is a total of 6. 3 will go into both 6 and 3. 3 will go into 6 2 times. And 3 will go into 3 1 time. So the factors actually reduce down, and that's the actual factors. Now, if I were to FOIL that back out, 3x times 2x is 6x squared. -3x minus 4x is -7x, and -2 times -1 is +2. So that's just sort of having to go back and remember how to factor. And the other thing is if you get stuck factoring, what could we have done is we could have used the quadratic formula, -b plus or minus b squared minus 4ac over 2a, right? where this is the A, B, and the C up there. So if you get stuck with factoring a trinomial and you're trying to find its zeros or its factors, you can always use the quadratic formula too to do that. So basically, we started with 6x cubed minus 19x squared plus 16x minus 4. We started the factoring by finding a zero on the graph that was obvious of x equals 2. That came from the factor x minus 2. Then we used long division, divide that out, and then we factored it to get our 3 zeros. Okay, so a little bit of a long process. Most of the assignment is going to be on long division and synthetic division. Then there'll be a couple problems that are longer like this. I think there's only 10 questions on the assignment, so you're not overloaded because some of these do take quite a while. All right. And I'm not really going to go over this. This sort of confuses what we're trying to do today. All right, so this is just a reminder of what we talked about. Either before you divide, long divide, you got to write the dividend and the divisor in descending powers of the variable, including all degrees, right? If there's one not there, you just put in a zero coefficient. That's what that says. Insert placeholders with zero for coefficients for missing powers of the variable. Okay, so before we go into synthetic division, I want to just go through one more long division problem to make sure we understand what's going on there. Maybe one that is missing a term. Yes, so let's do this. So we're going to take, where's one? Yeah, let's go 7x cubed plus 3. And we want to divide that by x plus 2. All right, so we're going to use long division. All right, so what goes inside the little house here is this first one. So it's 7x to the third. Now, this is where we got to have placeholders. That starts x cubed, so I got to have an x squared and then x before I get to the constant. So what I'm just going to do is put in placeholders of 0x squared plus 0x and then plus 3. So see, I haven't changed the value of that binomial. I just added 0 to it twice. When you add 0, we're not affecting anything, right? And then I'm going to put the x plus 2 out here. And then remember what we say. We say, okay, x times what is 7x cubed? Well, that would be 7x squared. 7x squared times x is 7x cubed. 7x squared times 2 would be a positive 14x squared. Now, here's the part you have to remember. I'm subtracting, so I've got to change the sign of both terms. Or how many ever terms are down there. That's going to add to 0, and then that's going to be negative 14x squared plus 0x. Same thing. X times what is negative 14x squared? Well, that would be negative 14x. Negative 14 times that is negative 14x squared. And negative 14 times 2 would be negative 28x. Change the signs to subtract. That's a negative 28x, so I've got to change that to a plus. So then I have 28x, and then I got to drop down the last one, a plus 3. All right, and then x times 28 is 28x. So that would be 28x plus, what's 28 times 2? 56. Change the signs. Now this time I do have a remainder. So that's going to be negative 53. All right, so x plus 2 is not a factor of that 7x squared plus 3. But the way I would write my answer is 7x squared minus 14x plus 28. And I can either write plus a negative or minus plus a negative 53 over x plus 2. So for the remainder, you put that remainder over what you divided by, just like you would with numbers. All right. So x plus 2 goes into 7x squared or 7x cubed plus 3 that many times. All right. Now, there is an easier way to divide, okay, which is called synthetic division. The thing with synthetic division is that you have to have a linear binomial here that you're dividing by. It can only be x plus or minus a number. So if there was an x squared or anything other than just an x plus or minus a number here, you would have to use long division. So let me show you synthetic division. It's a little bit simpler. It just goes quicker. All right, so now we're going to talk about synthetic division. And most of these, a lot of these, it makes it a lot easier. So there is a nice shortcut for long division of polynomials when dividing by the divisors of the form x minus k. So what you're dividing by has to be x minus some number or x plus some number. All right, and it's called synthetic division. The pattern for synthetic division is of a cubic polynomial summarized as follows. All right. And I'm not going to go through that. It's going to be just easier to show you. So let's say we want to divide this right here. Let me go ahead and write it over here. X to the fourth minus 10x squared minus 2x plus 4. And we want to divide by x plus 3. Okay, so x plus 3, what we're dividing by is in the form we can do, so we can use synthetic division. Here's how synthetic division works. Number one, we still have to have all the placeholders or all the values of x, the degrees of x accounted for. All right, so in this one, we're missing an x cubed. So what we're going to do is we're going to have to fill in a 0x cubed. Now, on synthetic division, instead of putting down all the variables, all you do is you write down the coefficients. So the coefficient of x to the fourth is 1. So I'm going to write down a 1. And then I've got to include the x cubed. So I'm going to write down the coefficient of 0. And then x squared, the coefficient of negative 10. Negative 2x, the coefficient of negative 2. And then 4 is the constant. All right. And then out here on the side, I'm going to draw a little half box. And what I do is I put in the 0 that comes from this factor. If I were to set that equal to 0 and solve it, it would be -3, right? So basically, it's the opposite of whatever that is. It's the value of k, because they said k was x minus k. So I'm going to put in a -3. And then I just sort of draw a line down there. That sort of takes care of the subtraction part of long division, is when I change that sign. Now, here's what we do. We drop the first number coefficient down. All right? Then we take the number up here in the half box and multiply it by that result. -3 times 1, and then it goes underneath the next number. So -3 times 1 is -3. Then I add those two numbers together to drop down the next one. 0 plus -3 is -3. And then I do the same thing. I multiply. -3 times -3 is +9. Then I add. -10 plus 9 is -1. All right. I multiply. -3 times -1 is 3. All right. I add. -2 plus 3 is 1. Then I multiply. -3 times 1 is -3. And then I add. That's 1. Now, what's on the bottom are the coefficients of my result. Okay? Now, which variable goes right here? Well, basically, whatever degree you start with, once you divide out a factor of x, you're going to be left with a polynomial that's one less degree. So if I started with an x to the fourth, then basically what happens is this starts with x to the third, one less than that, and then it just works its way down. This becomes an x squared. This becomes an x. This becomes a constant, so I'm going to put plus. And then this right here is my remainder. So what I have is x cubed minus 3x squared minus x plus 1 with a remainder of 1, which means that's going to be plus 1 over, now divided by x plus 3. So to me, that's a lot less time consuming than the long division. And I'd much rather do it that way right there. Okay, so once again, x plus 3 does not go into that polynomial evenly. It had a remainder. But that is what we call synthetic division. All right, let's see if they give us another example of synthetic division. And there's just them walking through the same thing. All right, so they don't have another example. So I want to do one more example of synthetic division before we move on, because this is what we're mostly doing. So let's have 3x to the third. Oops. Minus 17x squared plus 15x minus 25 divided by x minus 5. All right. So what I'm dividing by, 3, 2, 1, 0. It's got all my, I don't need any placeholders. So that's just going to be 3, negative 17, 15, negative 25. And then over here, I put the opposite of that, which is going to be a positive 5. Drop the first number. 3, multiply. 5 times 3 is 15. Add. -2. 5 times -2 is -10. Add to 5. 5 times 5 is positive 25. And notice this last one adds to 0. So that means it's going to be a remainder of 0. Then my answer starts one less degree than what I started with. So since that's x cubed, this is going to be x squared. X plus 5. So I get 3x squared minus 2x plus 5 is my answer. No remainder. All right, any questions on doing that synthetic division? All right, let me pull up the assignment again real quick so I can make sure the next thing we do is what's going to be on the assignment. We're ready for 2.3. View. All right, so on your assignment, the first problem deals with synthetic, second problem, long division, third problem, long division, then synthetic, use synthetic and factor like we did, synthetic. Yes. Yeah, just find your seat anywhere there, Martise. All right. So that, and then the last problem, the rational zero test. Okay, so just to go back up and let's just review everything we've done so far. Because you're going to have a problem like this from the start on your assignment. So we started with this polynomial 6x cubed minus 19x squared plus 16x minus 4. All right. On your assignment, they're going to actually tell you, kind of like they did here, they're going to tell you that there is one factor they know of whatever it is. So in this case, this is what it is. You're given a polynomial. They're told this is a factor. So what we want to do is completely factor the rest of this. So first thing we did was divide x minus 2 into that. We used long division. You could have also used synthetic division, right? And then we found that it factors as x minus 2 times 6x squared minus 7x plus 8, if I can read or plus 2. My writing's bad there. And then we just factored the trinomial to get it completely factored, which you could have also used the quadratic formula, and it completely factored to this right here. So there's going to be a problem on the assignment that's exactly like that. All right. Where you're given a factor, you got to find the other two factors by dividing out the first one and then factoring a trinomial. Okay. So that's going to happen there. And then we talked about synthetic division, which is an easier form of long division. And really on the assignment, it says to use long division. But if it fits to use synthetic, you don't really have to show your work. So really you can use synthetic division almost all the way through this assignment, unless you just want to do long division. Now, here's the last thing. What do we do if we have this big long polynomial, or we have a polynomial, and we can't tell by the graph and they haven't given us any of the factors? Okay, and that is where, well, let me get to it. We'll skip over the remainder theorem. All right, real quick right here, I'm just going to quickly, they're asking you to show that x minus 2 and x plus 3 are factors of that. Well, if you divide and it comes out with no remainder, then it is a factor. So that's what they did. They put 2, 7, negative 4, negative 12, 18, and positive 2, and got a remainder of 0. And then if I take what's left, which is now, that would be what, 2x3 plus 11x squared plus 18x plus 9, and then I do synthetic division by the negative 3, and if I get a 0 again, then both of those are factors. So, but that's not going to be on the assignment. The remainder and factor theorems. All right, the rational zero test. This is the last thing that we're sort of going to cover. And actually, let me pause. It is time to, by the way. So now, the rational zero test, what this is it's a way to give you an idea of what zeros are, or what zeros there may be, called the rational zero test. So let me show you how that goes. And this goes if we don't have any other way to find a factor. That doesn't make a lot of sense. So what I'm going to do is I'm going to go down. To use the rational zero test, first list all the rational numbers whose numerators are factors of the constant term and whose denominators are factors of the leading coefficient. So what we're going to do is we're going to come up with different numbers that could be possible zeros. The way we come up with those numbers is we look at the constant term, which is the last term that doesn't have a variable, and we look at all its factors. And we list all its factors here, the positive and the negative of each factor. The denominator comes from the leading coefficient. All right. Same thing, we list all the factors there. And then we create all the numbers and fractions that could be made out of all those combinations. So let me show you sort of how this works. This one's pretty simple. So it says to find all the rational zeros of x cubed plus x plus 1. Okay. The two numbers that we're concerned about to find the possible zeros is the constant and the coefficient of the first term. Okay. And what happens is the possible I hate the way this writes. Zeros, that is possible is what that says. Come from the, what do we say? The numerator is from the constant term. So the constant term is 1. Well, the only factors of 1 are 1 times 1, right? 1's the only factor of 1. So the only possible factors are positive 1 and negative 1. So I'll write it as plus or minus 1. Same thing, the lead coefficient is 1. The only thing that multiplies to 1 is 1 and 1. So basically, what happens is this right here will tell me what are possible zeros of this polynomial. Not all of them are zeros, but at least are they're possible rational zeros. Okay? And the way you do it is the numerator could be either 1 or negative 1. The denominator could be either 1 or negative 1. So what I could create is the numerator could be positive 1. The denominator could be positive 1. The numerator could be negative 1. And the denominator could be positive 1. Or the numerator could be negative, let me say positive 1. and the denominator could be -1, or the numerator could be -1, and the denominator -1. So based on those two factors, those 4 are my only options. That's the only numbers I could create. And then as I simplify, this simplifies to 1, this simplifies to -1, this simplifies to -1, this simplifies to +1. So really, it doesn't matter if they repeat. The only two possible zeros of this are either 1 or -1. Okay, those are the only two places, only two rational possible zeros of this. Now, what I can do is I can now use synthetic division to see if either one of those is an actual zero. Okay, if I was wanting to factor x cubed minus x plus 1, what I could do is I could use x3 plus x plus 1. That would be the same thing as x cubed. If I was wanting to divide, I would have to use a 0x squared plus x plus 1. And then to use synthetic division, I would use 1, 0, x plus 1. 1 and 1. Now, the 0 of 1 comes from the factor of x minus 1, right? And the 0 of -1 comes from the factor of x plus 1. So actually, right here on my synthetic division, I'm actually putting the actual 0. So if I want to see if +1 is an actual 0, what I'm going to do is I'm going to divide that and see if I get a remainder of 0. So I'll drop 1. 1 times 1 is 1. That's 1. 1 times 1 is 1. That's 2. 1 times 2 is 2. Remainder of 3. So I know 1 is not a 0 because it doesn't go into that polynomial evenly. So I can try it again with -1. So let's try -1 here. And then 1, 0, 1, 1. 1 drops. -1 times that's -1. That's -1. -1 times -1 is +1. I get 2. -1 times 2 is -2, which is a remainder of -1. So neither one of those are actual zeros. Okay, so what that means is that if there are any places where this crosses the x-axis, they're not rational, unless I did something wrong. Let's go ahead and see what they... Yeah, you notice there when they graph that, it doesn't cross at -1 or 1. It's right there, which is an irrational number. And basically, we could use our calculator to get a good approximation. But we're not going to be able to use the division or the rational zero test because that is an irrational zero, right? An irrational number is a number that goes on forever with decimals without ever repeating. All right. So just like they say, we know the real zero is not a rational number. Okay. On that particular problem. So let's see, on the assignment, it's going to give you one. It's going to ask you to use the rational zero test to list all the rational zeros. And then it wants you to find all the rational zeros. All right, so here's the last thing. So what I'm going to do is I'm going to go give you one more example here. And I'm going to go right here. So what we have is 4x to the 5th. Show you how this is going to work on your assignment. Minus 8x to the 4th. minus 5x to the third plus 10x squared minus x or plus x minus 2. The first thing we want to come up with are the possible rational. God, this thing will not write. Zeros. So remember, we got to create this fraction. The numerator comes from the constant. What are all the factors of 2? Well, 1 and 2, right? 1 times 2 are the only two numbers that multiply together to give you 2, right? So it would be plus or minus 1 and plus or minus 2. Now, 4. What are numbers that multiply to 4? Well, it could be 1 times 4, or it could be 2 times 2, right? So 1, 4, and 2 are all the factors of 4. So it could be plus or minus 1. It could be plus or minus 2. Or it could be plus or minus 4. So the first thing you're going to be asked on your assignment now is, what are all the possible rational zeros that come from this? Well, if I start with positive 1, well, you put here, I can have 1 over 1, 1 over 2, or 1 over 4, right? And it's going to be positive or negative. So I can either have 1 plus or minus 1 over 1 is 1, plus or minus 1 over 2, or plus or minus 1 over 4. So there are 6 possible rational zeros, 6 different possible places where this graph could cross the x-axis. And then with 2, I could have 2 over 1, so I'm going to have plus or minus 2. 2 over 2 simplifies to 1. I've already got 1 listed, so I'm not going to list it again. And then 2 over 4 reduces to 1/2, so that would be plus or minus 1/2, so I'm not going to list it again. So that's the first part of this, is it wants you to list all these possible zeros. All right? Those are all the possible rational zeros. Now, the next thing it asks you to do is find all the rational zeros. Okay? Which there could be up to 5 of them, right? Because it's an x to the 5th. All right? So, this takes a little bit of time. What I'm going to do is I'm going to start, I can only use synthetic division with my whole numbers. Okay? I cannot use synthetic division with a fraction, because it's got to come from the factor x plus or minus something. A fraction would come from, right, if I was looking at x equals 1/2, that comes from the factor of 2x minus 1, right? Because when I set that equal to 0, I add 1, divide by 2. I cannot use synthetic division with the fractions. I would have to go and set it up like this and use long division. So maybe it'll work out with the whole numbers that I can use with synthetic division. So I'm going to start with, this goes 5, 4, 3, 2, 1. So I'm going to start with 4, -8, negative 5, 10, 1, and negative 2. And then I'm going to start with positive 1 and see if that's a rational zero, which means it would have zero remainder. So this is 4. 1 times 4 is 4. That adds to negative 4. 1 times negative 4 is negative 4. That's negative 9. 1 times negative 9 is negative 9. That's 1. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. Notice we do get a remainder of 0. So x equals 1 is a 0. Right? Now, instead of going ahead and adding it would be x4, x3. Okay? What I'm going to do is I'm going to go ahead and set this up so I can use check negative 1. I don't have to go back to the original. I can go from here because it's still going to be a factor of this if it's a factor or a 0. So I'm going to use negative 1 as my next one to see if that is. All right. And I don't have to worry about this 0 anymore. So I drop the 4. Negative 1 times 4 is negative 4. That's 0. 1 times that is 0. That's negative 9. Did I get this right? Negative 1, that's 9. And that's 10. It looks like this one is not working. I thought when I did it earlier it worked. So I'm going to make sure I didn't do something wrong. That's negative 10, which would be a negative 8. So this one is showing a remainder, which is showing that negative 1 is not a factor. Let me see, negative 4, negative 9, 4. 1 times 4 is negative 4. Oh, that's a negative 8. That's the problem. It's very helpful if you add and subtract correctly. So let me back up. I messed up right there. I thought I messed up on that. Negative 4 plus negative 4 is negative 8. God, this thing, the way it writes drives me crazy. All right, negative 1 times negative 8 is 8. Negative 9 plus 8 is negative 1. Negative 1 times negative 1 is positive 1. That's 2. Negative 1 times 2 is negative 2. A remainder of 0. So x equals negative 1 is also a 0. And we started with x to the 5th. This was x to the 4th. This is x to the 3rd, right? If I wanted to write it out, the remaining, that would be x to the 3rd minus 8x squared minus x plus 2, right? So now I'm going to I can use positive 2 and negative 2 as synthetic division. So I'm going to go 4. How much time we got? About 3 minutes. 4, negative 8, negative 1, and 2. And I'm going to check 2. That's 4. 2 times 4 is 8. That is 0. 2 times 0 is 0. Negative 1. 2 times negative 1 is negative 2. And I do have a remainder of 0. So 2 is also a rational 0. And notice what I'm left with, that came from 4x3. This is 4x squared. And that's x. And what I can do from here, instead of continuing now, I'm down to 4x squared minus 1 equals 0. I can factor that now. I don't have to use synthetic division. I can factor that to the difference of squares. And you notice that's going to be 2x plus 1. Golly, this thing will not write. 2x minus 1. And then I can take both of those, 2x plus 1, and set it equal to 0. And I subtract 1, divide by 2, and I get x equals negative 1/2. That's my fourth rational zero. And then if I do the same thing there, I add 1, divide by 2, I'm going to get positive 1/2. All right. And then that's how the last problem on your assignment is going to work. Very similar to that right there. And